This animation is to show you how to use the Mooncalc animation simulation for our lunar phase activity. So when you open up the link, the screen may look something like this. We want this to be kind of centered near Lawrence. To make sure of this, you can go over here. Here's where the location is. Type in over here. You can just type in our zip code, 66049, and hit enter. Type that in, and sometimes there, a drop-down list will come. Doesn't really matter where, just any 66049 is close enough. And then it zooms in way too much, so we need to zoom out. Use the zoom out key about 5, 6, 7, 8, until you can see the whole US. We want to be able to see this a little more, and about there. Okay, give it a second because it's trying to catch up with me right up here. And it may look a little bit different for you depending on the time of day where this is set at here. What you're seeing here, this difference between the dark and the light over here is what's called the Terminator. No relation to the James Cameron films. But what happens here is you change the time. What's happening here, that's where essentially day is turning into night depending where you are. You want to set your date. Go over here, click on here, and set to whatever date is on your data sheet. So if I want to set this to like February 1st, boom. And then, so this will what it look like on February 1st. Right now, notice this thing is set around about 7:30 in the morning. So here's the date you want. The data you're collecting is, first off, you want to set this to sunrise. Sunrise, you want to slide this around until the Terminator is pretty much, so this line here is pretty much right over Lawrence. The sun is just now coming up. So that's sunrise. It's about 7:30 in the morning. And then you want to look at the moon over here and jot down the information about it. Its azimuth is 141 degrees, 142. You can run it to there. Notice its location is about in a southeasterly direction. Those are the locations you're putting down for it. Its phase is a waning crescent. And that's, I think, what you're doing for that one. So then you move this to noon. So just slide this over to noon, right about here. And do the same thing with the moon again. Again, phase is not going to change over the course of a day, but its azimuth, about 212 degrees. Its location is southwest or south-southwest in there. Then you set this to sunset, which is, slide this over until sunset. One thing you notice here, this yellow and red line here, this is essentially where moonrise and moonset are. Notice it also crosses right here at about 15. That's about where the moon is setting. So the moon is setting before sunset here. So here's sunset. So again, record the information. If you want to know moonrise and moon setting time, that's what the band of this thing is here. So here's moon setting time is about, you can look at the time over here a little more specific. That says moonrise, but moon set is 15:03. Notice it even gives it to you over here. Keep in mind that's like 3:03 in the afternoon. And then moonrise was way back over here at about there. Notice moonrise at 5:12 a.m. So those times are sitting down right here. And sunrise, you can, like I mentioned, sunrise is at about 7:30. Sunset at about, looks like at about 17:45, which is about 5:45. Okay, just take these, this is in military time, subtract 12 if it's over 12, so that's about 5:45 in the afternoon. So then, there's your data for one day. Go to the next day, change this over here to maybe the 5th or something, and do it all over again. So you're going to do this for the days specified, but that's the data you're collecting for these things here. And it's just a matter of sliding the slider back and forth at the appropriate times, and that should get you your data. Once you get your data tables filled in, you go ahead and answer all the questions. If you have any questions, please see me about it. Thank you.